Hey everybody, and welcome back to Brooks Hobby Shop for part 7 on the Roadside Find 1968 MAGNAVOX. Today we will finally get into what I would have thought we'd have gotten into in part 2, but those following this series know why we didn't. We're going to go ahead and start checking out the chassis in this television. We're going to begin by checking the Flyback transformer. This is the very first part I go to in any unknown television that has a tube-type deflection stage in it. Any television I am unfamiliar with, the moment they come in and I first go into them, the Flyback is the first thing I go to because it is such a critical part. And not one of the easiest components to sub out or necessarily find a replacement for, especially in color televisions. I don't really worry so much about the yoke. They can be subbed pretty easily if you just have the right general type of yoke. You can substitute a deflection yoke. Picture tubes, of course, can be pretty readily subbed, but the Flyback transformer is a part that really kind of everything hinges on as far as how smooth or how hard a restoration's going to go. So this is always the first thing I go to. Even a vertical output transformer, that can be subbed. Pretty much any part in a television can be replaced or subbed easier than the Flyback. So if I followed my normal routine, I would have went ahead and checked this just as soon as I got this thing into the shop. I would have checked this first. But of course we got all this rat and roach debris. So since I had already decided I do intend to keep this television, that's why I have not even bothered to check the Flyback in this sucker. Now, I've already put a new floor in the cabinet and I have still not checked the Flyback. And I've got kind of a bad feeling about it, but I'm not going to regret anything that's been done already. But for those just joining, we already know that we have a smoke component down in here. And the Flyback actually seems to be looking all right. I thought when I first saw this that that was probably a smoked selenium type focus rectifier. But then while I was doing the chassis cleanup, I found the focus rectifier right here. So that means this is almost undoubtedly, if it's a diode, it's almost undoubtedly the boost rectifier. Well, while it was in the cabinet, I'd assumed this was a bleeder resistor for the picture tube. Because televisions from this era, it was pretty common practice for manufacturers to have a bleeder resistor from the second anode of the picture tube to ground to discharge the picture tube when the television was turned off for safety for anybody working around inside the television. Manufacturers used to actually care that much and go that far. But it turns out that our focus rectifier is actually here. And since I see no boost rectifier diode anywhere underneath the chassis, that means, or on top of the chassis, they have a kind of specific look, but that means this is probably the boost rectifier. And realizing that the chances of the Flyback being bad are heightened. Anyway, I still haven't procured any service literature, any schematic on this specific television, but for the beginners out there, I'm going to show y'all a schematic diagram of a television that seems to have a very similar flyback stage to this one. For demonstration purposes, I have the Howard W. Sams data here for a Sylvania console that is also 1968. And here, let me get my camera on it. All right here we see the flyback transformer. Okay, the flyback transformer is also known as the horizontal output transformer, and it's also known by some as the high voltage transformer. It carries on a multitude of duties inside a television, a color television in particular, including pulses for the convergence and AGC sync, you name it. Anyway, looking at the transformer, you see right here, we've got the horizontal output and the high voltage rectifier tubes. Okay, the plate of the horizontal output comes around down here and connects to the flyback right here, and the plate from the high voltage rectifier connects to the flyback right here. Alright, this is called the plate to plate check, and generally you're looking for a reading of less than 1,000 ohms. In this Sylvania it's showing 570 ohms. But okay, here's our focus rectifier right here, and it is right there in the plate circuit of the horizontal output. And if we come on down here, here is the boost rectifier right here. Now this Sylvania uses a 6BK4 shunt regulator for the high voltage, which our MAGNAVOX here does not have. But this is a pretty good, reasonably close representation of the basic kind of circuit we're working with here. Okay, the most important and first check I go to in any tube type television with a tube type deflection stage is I do the plate to plate reading between the plate of the horizontal output and the plate of the high voltage rectifier. Depending on the size and circuit configuration you'll find some measuring down, like 200 something ohms, and you'll find some measuring like 800 something ohms. When you don't have data for the specific television you're looking for, you just got to be comfortable if you end up with something believably less than 1,000 ohms. So I'm going to connect one probe of my meter right here, and I'm going to connect the other probe right here to check this winding right here for the high voltage. It is the winding in the transformer that has the highest step-up ratio. But also, right over here, we've got the damper tube. And still with my probe, without moving this one, I'm going to leave it connected right here. I'm going to also measure from here to the cathode of the damper tube. Now, this one will usually be, a lot of times it might be less than 10 ohms. I would say you're looking for believably less than 20 ohms, but a lot of them aren't even going to be all of, 10 ohms. So 20 ohms is kind of an exaggeration. But if we follow the cathode here, all the way down and come across, we'll see that it goes into the flyback right here. And all of these windings down here are, comparatively to this one, low resistance. So I'm looking for believable continuity from plate to plate, from the horizontal output to the high voltage rectifier. Sorry for the shaky camera, y'all. I'm nervous about this test. And then I'm going to measure from here to the cathode of the damper tube. And then finally, assuming all that goes well, I'll measure all the way from the plate of the high voltage rectifier to the damper tube, just to be OCD and double confirm that. Alright, as y'all can see, I've got my meter set to the times 100 ohm range to do this, to go from the plate of the horizontal output tube to the plate of the high voltage rectifier. So I want to go ahead and disconnect this. And be careful when you're doing this, y'all, because a lot of times in a lot of old televisions, the wire from the plate of the high voltage rectifier to the flyback will be very brittle, and a lot of the old wax encased flybacks, you can easily damage the flyback just by unplugging the cap from the high voltage rectifier tube. Anyway, my second probe is going to go right here, and we have the plate of the horizontal output right here, and if we follow that on around, it's just more convenient for me right now to have my meter clipped right here, and this is where it's going to stay for both the plate-to-plate test and the plate-to-cathode test on the damper tube. So let me see if I can get y'all set up here. This is going to be kind of awkward because my tripod is positioned to where now y'all are going to actually have a better view of my meter than I do. But I'm not being too precise about this. I'm just, we're going to be using the very top scale on the meter. So one will be 100 ohms and so on and so forth. Right there at the top on the resistance scale. Alright, so I don't have a manual to show me what it's actually supposed to read, so I am now connecting my probe to the cap lead to the high voltage rectifier contact. I'm on it right now, and of course, with my luck being what it is, it's already looking like that winding is actually opened. That is one of the most common conditions I have ever found in tube type color televisions. Color televisions, there's a reason you don't see a lot of people playing around much with tube type color televisions from this era. Okay, I'm already satisfied right now. We'll look a little closer in a moment, but I'm already satisfied that's open. So, unfortunately, it looks like we've got a bad flyback in this, which rewrites what I talked about in an earlier video about this television's final moments probably being fluctuating focus and everything, when I thought that smoke component in here was a focus rectifier. But anyway, I've still got my meter. I'm not going to switch it right now. It's still set to the times 100 ohm range, so just for reference, there's 0, and it's probably going to show right at 0 or just slightly above it here. Probably going to show just a full 0. Alright, that is the cathode terminal on the socket for the damper tube. Okay, just for the heck of it, I am going to flip this down all the way to the resistance times 1 range, and now that 1 will actually be 1 ohm. And I'm going to have to recalibrate the 0 on my meter, almost undoubtedly. Like I said, not being too precise, but I've got my positive and negative probes shorted together right at the moment to do this. And you see my meter's kind of got a sketchy potentiometer in it. All right, there we go. And that throws me off on the top end. These old vacuum tube voltmeters, you got to get used to recalibrating them. I'm used to it. And that's still effectively 0. So once again, connected to the same point I showed you between the two, I am now going to once again measure the resistance to the cathode terminal of the damper tube. And it is showing very, very believably just a little better than 3 ohms if I took the time to go ahead and calibrate my meter absolutely precise. It's probably about 3 ohms. So we've got continuity from the plate circuit of the horizontal output to the cathode of the damper, and looking open probably as a barn door from the plate of the horizontal output to the plate of the high voltage rectifier. I'm going to go ahead and switch this down here to the times 1 million ohm range, and now that 1 will be 1 million ohms. And since I just switched from a low resistance range to the highest resistance range, I'm going to have to recalibrate again. That is good enough for me, and of course now it pegs up here on the top end. All right, one more confirmation. And I'll bump that just a little bit. And just a little bit more. Sorry for the OCD action, y'all, but... Okay, once again, from the plate of the high voltage rectifier to the plate of the horizontal output. And it is showing just a little less than 1 million ohms. That is entirely too high. I'm looking at the meter now on the screen of my phone through the camera. It's looking like about, from the angle I'm looking, with a little parallax here, all of a, right at about 900,000 ohms. Okay, we got a flyback that's going to have to be looked at a whole lot closer, and probably I'm going to have to find a replacement for it, but we're going to continue on with our chassis checkout. We already know what the next video is going to be. It's going to be me pulling all of this out of here so I can do more checking and really take a close look at that honey. For the beginners, this is why I always go straight to this part. I don't even bother checking for blown fuses or anything. I go straight to the flyback in a television every time. If it is tube type, I go straight to the flyback, because unless it's you've got a project like I've got with this one, which you're really ultra determined on, you can save yourself a lot of trouble and go ahead and discover a bad flyback and go ahead and determine then whether or not you want to go any further with it. But I'm already, I'm already locked in and determined on this one. So that's the reason you don't hear me panicking too much here. I've got a couple of sources in mind where I might be able to come up with a replacement for this. And also, these chassis were probably used with different screen sizes. So if you consider maybe this same chassis, this one's a 19 inch. If it was also used in like a 23 inch, that'd be a different Flyback. If it was also used in some 25 inch, like 25 inch console models, that would be a different Flyback. So there's multiple Flybacks, you know, to explore probably for this chassis to come up maybe with one that will just wire right in like the original. Again, for beginners, this is the most common place you will find a Flyback transformer bad. Right here on this final step-up winding between the plate of the horizontal output and the plate of the high voltage rectifier. I have seen this, I think, in my life close to, if not more than 100 times. If they're not arcing and trying to light up like the 4th of July, if they're bad, normally you don't have problems in the lower windings here, the primary and everything. Normally, if one's got a winding problem, it's going to be right here. But for the purpose of this video, even though it might seem crazy at this point, I'm going to ignore that this thing just failed that test in flying colors. I'm going to ignore the fact that it's one of the hardest parts, especially in a color television from this era, to come by. I'm going to pretend that it checked fine, and we're going to keep on plugging away with the chassis. Also kind of operating on the philosophy, you know, when you've got things that you can't fix, go ahead and proceed with what you can. But again, like I said, I'm locked in on this one, so this is kind of maybe a unique scenario we got going on here. Anyway, if assuming your Flyback check's good, the next thing you want to go to as far as parts that will probably, some of them need to be replaced, if not all of them, you want to go straight to the electrolytic capacitors. And we've got these right here, and we've got another one tucked back here in the back behind the high voltage cage. And if you squint, you can see we've got a little tiny solid state type one right here, radial leaded. And pretty doggone sure that one's going to be bad. Usually when you find this type in a television that's this old, they're totally dried out. But all right, we're going to go ahead and try to get an idea about the electrolytics in this. A quick note here, lest it seem I'm overlooking the obvious. It should go without saying, but for the beginners, just in case, anytime you see tubes with the gettering in them in this condition, all white and milky like that, instead of looking kind of silver and everything like this, anytime you pull the back off a television and you see tubes looking like this, or any of these others here, that is a sign that air has gotten into them, and you do not, under any circumstances at all, apply any power to a chassis whatsoever. You never ever apply any power at all to a chassis that has tubes in this kind of condition, and you're just going to cause damage galore. You do not variac a chassis that has tubes in this condition. You do not dim bulb it. You go and apply power to a chassis that has aired tubes in it like this, and you are going to just multiply your problems tenfold, because you're bound to smoke a bunch of carbon resistors, and you're just going to add to your grief and your parts list and your expense and the work you have to do. So don't let temptation get the best of you. Don't get curious and wonder like, gee, I wonder, will it do anything at all? Yeah, it will. It'll do something. It's going to smoke a bunch of parts that you're later going to have to replace, in addition to replacing all the tubes that have gone there. Never ever apply power to a chassis that has tubes in this kind of condition. Replace the tubes first. I've got these tubes. I already know I've got them, so for me, it's no problem. We've got 5 tubes that I've counted in this that air has gotten into, and for some that'd be a deal breaker, but for me and this television right here, right now the major worry is this. Electrolytic capacitors and tube type equipment will most often take the form, as they do in this, of multi-cell capacitors, usually containing 2 to 4 inside of a single can, all sharing a common negative. Electrolytic capacitors are polarity specific, and you can see in this one we have 4 capacitors actually. We've got a 180 microfarad rated at 350 volts, an 80 microfarad rated at 200 volts, a 150 microfarad rated at 200 volts, and tucked down in here, if you can see it, if I can get the camera on it, we've got a 100 microfarad also rated at 200 volts. And they're all sharing a common negative. This can is the common negative for all of them. And you will see that it is mounted directly to the chassis. So this electrolytic right here is chassis grounded. Now, that said, up here, this television has a voltage doubler type power supply. It's basically an AC-DC set. And you will often find 2 capacitors like this. This one right here has 3 sections, and this one right here is a single. This one right here is actually a 400 microfarad rated at 200 volts. And in this one right here, we have a 160 microfarad rated at 350 volts, a 100 microfarad rated at 350 volts, and a 60 microfarad rated at 350 volts. So this one right here is the only one that's mounted on the chassis that is just a single unit. But you notice it's got an insulator around it, and for the beginners, you want to pay particular attention to that. It is there for a reason. If you see one with an arrangement like this where that is damaged, where the bare can underneath is showing through, it's got a can like this underneath that insulator, you do not want to get between the can of this one and the can of this one. You will, most of the time, receive a pretty hard shock, because this one right here is hot grounded, and that's further indicated by the fact, if you can see it, that it is mounted on a phenolic insulator. It is not, unlike these others, grounded right to the chassis. This one right here has a phenolic insulator right there. And sometimes these phenolic insulators were used by manufacturers just, to make the proper size mount for an electrolytic, but most of the time when you see a phenolic insulator, and especially when you see both a phenolic insulator and a capacitor with an insulator around it, be careful about that when you replace it. A lot of the replacements won't have an insulating wrap around them, and if you get between the can of this one and this one, you are getting right into the power supply circuit and it will bump you hard enough. Trust me, it's happened by accident, but it's happened to me multiple times in my life. You won't do that very long. It's going to let you know something right quick. It'll alert you you just made a big mistake. But I want to point that out for people, because some people doing this are going to have like pacemakers and heart rhythm trouble, and you don't want to get between a hot ground and a cold ground. Anyway, the other capacitors in this television, unlike a lot of older ones, we're not going to be particularly worried about, because a lot of them are these orange drop type and the ceramic disc type. This one doesn't have the old color-coded bakelite encased, hermetically sealed capacitors. They were called Black Beauties. Or a lot of people call them bumblebees, like they call the wax cap type, that's in a lot of older equipment. This is a television that was manufactured in the late 60s, and by the time this television was built, capacitor design was really at a high art. So most of these that are epoxy sealed and these ceramic disc types, almost, I'm not even worried about even going and testing any of them. Most of the time, they're going to be acceptable if they're not just as good now as they were the day they were installed. Also, I've got the chassis sitting up using the high voltage cage, the Faraday cage, as a convenient prop for it. When you're doing this on these televisions, make sure your wire harness is secured. On this one, it still is. It's still bound real tightly at the chassis here, and around here we've got another binding for another part of the wire harness right here. But you don't want to strain, and break wires loose and then have to wonder like, gee, where did that break loose from? Where does that go? Down here at the Flyback transformer, you see I used a couple of zip ties, because there were some wires down here that weren't really secured, and I didn't want them flopping around, so I just temporarily zap strapped or used zip ties here to secure those. Anyway, getting around here to the underside of the chassis, one thing you want to do checking out electrolytic capacitors is just look at them. Really look them over real good. Look at the bases of them. This is the 4-section one. And you want to really get a good look at the underside of them and make sure it is not swollen out, that you don't see where the seals are pushed out anywhere. You want to pay particular attention to any acid leakage or residue from acid leakage, or where fumes have escaped around each terminal. You just want to do a really good physical inspection first and foremost. That'll clue you in on a whole lot. Since this television was manufactured in 1969, there is a chance, albeit I think somewhat a slim one, that they'll last right on and on, that these right now will still reform, and that they are still, actually maybe workable. I think this one and these two up here might just, withstand later on in this project a power-up. So I think they're probably that good at least. So in this one, I'm not going to go and disconnect all of that. I'm just going to do a good physical inspection. Here's that isolated one, and you can see right here, kind of, if you can squint and see in there, that it is physically the can of it, where it has these twist tabs here, locking it in place. It is physically, electrically isolated from the chassis. You just don't, it is not directly connected to the chassis. So you need to pay particular attention to that. And this other one right here, we can just barely see it. But a good physical inspection is the first thing you want to do. Also on the cans, any sign of corrosion, where it looks like corrosion has started coming through from the inside and they're looking all crusty and everything. That is a sign that, you know, even if it's still working at that moment, you need to replace it. It's about to go. Anyway, I've already mapped these out, and these multi-cell capacitors, you're going to have to get in closer than what I can show you, but the different sections of them have identifications on them. There's a half moon for one terminal. We'll get on down here to that fourth section. One will have like a half moon, another one will have a square, another one will have a triangle, and the other one will just have, in the case of a fourth section, no identification at all. I put a little dash there, but that doesn't mean that that's negative 200 volts. That just means that that's the one that has no identification, you know, like these others do. Half moon, square, triangle. Normally, in a lot of older equipment, I would disconnect these suckers and do an out-of-circuit check on them, because while they're connected in circuit, you've got the capacity of the entire circuit that's going to greatly add to the readings of all of them. But, and like right here, you can see this one looks like it's got a resistor going right between two terminals. So the capacity of this terminal and that terminal are joined right here through a pretty low ohm resistor. So all the readings I get on these are going to be high, but in the case of this particular project, all I'm going to do is just test each section and get the reading from them, just the full in-circuit reading as they are right now. It's always, you won't get an accurate test doing it this way of any individual section, but you will get an overall circuit capacitance test, which you can use as a comparison point later. Okay, I've just finished doing all of that, and as you can see here, the readings I got on most of them were pretty wild, and I had a couple here that were kind of alarming. This one right here on this 3-section one right here, I couldn't even measure it. It was just over range. And here we've got like a 100 microfarad checking 1,288 to 1,292 and so on and so forth. But right now I'm not really, you know, being critical. I'm just wanting all of this documented as a later reference, because part of the reason you're going to have a higher reading in tests like this is because this chassis has sat up for so long. Just about all the electrolytics in it now have developed some degree of series resistance, otherwise known as high power factor. And if they reform, that will lessen, and a lower power factor will cause some of these readings to come down. So I've just got these right here, all of this documented now just as a reference. I found one, don't forget sub-assemblies like our auxiliary control assembly right here. Here we've got a 100 microfarad at 25 volts that actually test effectively open. 0.001 microfarad with the negative here and the positive of my meter connected right here. And I'm going to have to look closer at it. And I'm very curious about this section up here, which just I could not obtain any reading on whatsoever. Digital capacitor testers like this, I think at the time I bought this one back years ago, it was about 80 something dollars from MCM, and that was a good price. You need to get one of these. You can't do load test or anything with these, but if you're disconnecting them and, checking them, the way, I normally would in something older, you can get a pretty good measurement of the actual capacitance with just a lower price meter like this. They're probably not much more than $100 now. But on a meter like this, a high power factor will result in a higher than normal reading. Like if you have a 100 microfarad and it's out of circuit and it's got a high power factor, you might connect a meter like this across it, and it might show like about 180 microfarads or like 215 microfarads, and that reading will be because of corrosion on the inside of it, and that's causing the series resistance, which on a meter like this will cause you to have a higher reading. So when I see a high reading like that, and it's not due to it being shunted in the circuit like this, that's always a clue to high power factor when I'm using this little meter right here. Anyway, our isolated capacitor up here gave a really good test, showing some series resistance, but it actually 400 microfarad reading 446. We'd probably get a pretty different reading, if we disconnected it, but this one right here I'm actually feeling pretty good about, and I'm kind of glad about that, because this one right here, ones like this, you can buy them very readily and all, but I kind of like the original aesthetic of this one, so if it's still actually that good, I'm happy. All right, let's see. Oh yeah, talking about sub-assemblies and not forgetting them, I forgot these two right here that are on the convergence assembly. We've got one right here that's a 5 microfarad at 25 volts, and we got another one right here that is a 25 microfarad at 25 volts. So we'll go ahead and test them right quick and see what we get on this. I just, for everything except that isolated one up there, on all these main ones, these multi-cells, I had my negative probe connected to a common chassis ground tie point right here. Anyway, we'll go ahead, if I can put this in here. It's not going to let me do it. Let's see, but we'll go okay, this is the 5 microfarad. All right, I got that one clipped anyway. Pretty sure it looks like we got a bit of a bulged seal here, but we'll give this a shot anyhow and see how it does. 5 microfarads, and look at there. This meter ought to be basically showing 1. This is looking like a bad capacitor here. Let's see how far back we have to go to actually get it to right there. Yeah, we've got I'm pretty sure we've got a bad capacitor here. So this one right here is checking open. This one on this control subassembly right here is basically checking effectively open. It's hard to one hand on camera, but now we'll go to this 25 at 25. And our positive is actually right there, so clip onto it. Yeah, and it won't stay. But now I'll just okay, it was not until I actually reviewed this clip that I realized that I had turned the camera off and then just continued right on prattling away to myself with no audience. Anyway, there we go. 25 microfarads at 25 volts, reading 17.46 microfarads on the 20 volt range of the meter. So, unless it is shunted, this one is also on its way out. Like I said, smaller electrolytics and all in old equipment like this, you're going to often find almost unilaterally they need to be replaced. Our 50 microfarad right here on the front of the chassis, same with it, 35.6 microfarads. So, but talking about a shunt, you can see that we do actually have a resistor going directly across it. You know, forget the rest of the circuit that's connected across it, but we got a resistor clearly visible right here, connected directly across this one. So, as I said earlier, the out-of-circuit test is always going to be the most accurate. But anyway, it's dark here now. And let me go ahead and see if I can remember everything else that I was trying to impart to y'all while the camera was off. Going through a chassis for the first time, if you've got circuit boards in particular, just, you know, give it all a good, thorough visual overview. But if you've got circuit boards in particular, you know, and, well, even if it's in hand-wired sections, look to see if you've got overheated and cracked solder joints around tube sockets, like here for that 6AQ5 right here, which is actually looking fine. But cracked solder joints, the problem with that really increased once printed circuits got introduced into television chassis. For as long as there have been printed circuits, there have been cracked solder joints. It's just a prevalent problem with printed circuit board design. And another thing, while you're going through your initial inspection, I want y'all to look at this right here. Talking about cracked solder joints, if you look, we have got a very clear one right here, right where that circuit board is mounted to the main frame of the main chassis. You can see that one very clearly. And that's right at a mounting point for the circuit board, which is also invariably a ground loop. You need to look at all of these, and you will save yourself a lot of headaches if you just go ahead and inspect all of these eyelet points where the circuit boards are actually normally soldered to the chassis. Grounding was often done through these just because that kept manufacturers from running ground wires all over the place and cluttering up everything with just connecting the ground of one circuit to the ground of another circuit and so on and so forth. The chassis itself is an excellent conductor for that. So that was done through ground loops. One eyelet connects the ground from this circuit to the ground of another circuit through another eyelet. And cracked solder joints in these suckers are very common because you've got a copper circuit and then you'll have either like a copper or a steel chassis. But right here in these eyelets, for rigidity, they often used metal rings which were actually galvanized. And anything galvanized does not take solder and hold solder very well. So they would tin plate those suckers and put them on the board and then just flood the solder all over it and everything straight to the copper conductor on the board. But you can see very clearly right here where a crack has formed around this one. Those eyelets expand and contract thermally at a different rate from the chassis and the circuit board. It would have been a much more secure connection and longer lasting if they had just done away with those eyelet rings and soldered the board, the copper of the board, directly to the chassis. But instead, they've often got these galvanized eyelet rings there, just strictly for rigidity. And the plating will separate from them, the tin plating will separate from them and cause the crack. And also, it's just, you've got multiple, you'll have sometimes, multiple metals, a copper circuit, and then like a steel chassis. This one is copper, but you might have a copper circuit, a steel chassis, and then you've got this galvanized eyelet right here. Now, if you don't go ahead and tend to that, what you'll have is a television that when it's playing at an elevated volume, the picture will flash with the sound, and if people are walking across the room, vibration translated through the floor will aggravate these cracked joints and cause the picture to twitch and flinch and everything. And a lot of people will just go hog wild, swapping out tubes, thinking it's got to be a loose element in a tube. When in truth, all they're doing, even if it seems to cure it, it's just temporary, because in swapping out tubes to try to cure those intermittent conditions, what they're actually doing is they're applying some pressure to the board, which kind of exercises that crack a little bit, and the connection will remake for a little bit commonly, and then all too soon the picture will start flinching and twitching again, and again, when the sound is turned up, you'll have the sound kind of flashing, the picture kind of having these lines flashing through it in rhythm to the sound. So pay particular attention to these, and get a magnifying glass and just go through and really inspect all of these in particular, as well as everything else on the printed circuit board. This television appears to be very low hour, extremely clean. We don't even have like any sign whatsoever of like any kind of just a non-smoking environment. We don't have any sign of heat. Here's the combined vertical oscillator and output socket connections, and you see none of these even look like they've even ever really been hot. So we got to assume like an air-conditioned, non-smoking environment for this television. It's pretty rare to find like focus coils and everything, looking this clean still under a television this old. But that's another thing I wanted to impart. And also, even though I think we have definitely found the reason why this television ended up out of service, we're going to go ahead next and check our low voltage rectifier diodes up here. Okay, it's about time I got another meter. Can y'all see that at all? Anyway, we're on one now. And that is looking good. That is looking good. This meter is, oh gosh, it's going to depress me if I think about how old this old meter is. But anyway, it's my quick diode check, buddy. So that one's looking good. All right. So I'm gonna go ahead and clip onto the next one up here. And we'll see how it looks. All right, that's looking good. That's looking good. So, for right now, I think we've gone about as far as we need to go on this one at the moment. I thought at first this television probably had gone down just to focus trouble, but anyway, not so much. No, we've actually got a bad testing flyback in this, and we'll get into that in the next video. I've got no choice. I've got to go ahead and really check out the flyback in this thing now, and that'll probably be to no avail, but anyway, that'll be our next video. And as far as all the major points that I generally look at, this is my preliminary chassis inspection, at least on one as new as this and as clean as this. So until next time, y'all take care of each other and look in on those you love, and be good like you always are. Find something you love and enjoy, and don't let anybody tell you that it's not worth it, that you're wasting your time. Like some people might want to say, hey man, you're wasting your time on that. That sucker's got a bad flyback. We're going to get into it deeper, and we're still going to stay after this one, y'all. So everybody's got a right to their opinion, but yeah, I really want this. I want this old Delta System MAGNAVOX in my collection, and I want it working. So next video, we'll do a flyback check, and even if, and it probably will turn out that I've just got to hunt up a replacement for it. That'll be fine. I committed to this when I started it. And in the spirit of the holiday season, you know, as the holiday song goes, you know, if we've really got just a terrible, unusable flyback, we'll just have to muddle through somehow. Anyway, until next time, y'all, I've already said it all, and I won't repeat myself and go into a longer video. But y'all take care out there, and be good. Brooks Hobby Shop. We're out.